Hello everyone, my name is Sai. So now my topic is Shutter Map, a revolutionary internet backbone monitoring system. So let's imagine what happens when a single fiber optic cable breaks at an internet backbone. How do massive networks figures out in a milliseconds whether you are still connected today? We are exploring Shutter Map, a game-changing data structure that redefining how the internet monitors itself in real time. So, coming to the problem, the current internet backbone handles hundreds of thousands of links, updates every single second. That connections being added, removed, and verified constantly. The challenges. The current traditional data structures like Union Find were never designed to handle deletion efficiently. Meanwhile, methods like BFS, like Breadth First Search, are incredibly slow when you are running millions of queries per second. So now we needed something fundamentally different. So that's when Shuttermap comes into play. Shuttermap's genius lies in simple observation about real backbone networks. 99.7% of edges are part of cycles that are redundant. So there are two types of edges: reinforced edges and stress edges. Reinforced edges are part of cycles, removing them does not disconnect anything. But whereas stress edges, bridges removing them could break the network. So this is where Shuttermap gets brilliant. For the 99.7% common case deleting a reinforced edge, it operates in constant time, big O of one instantaneous. But what about stress edges? When one deleted what we call a fracture, Shuttermap triggers something called bidirectional component verification. Instead of checking the entire network, two search waves radiate simultaneously from connection points. If they met, false alarm and alternate path exists, no split. If one exhausts before meeting the other, a true split is confirmed. So the genius of Shutter Map is complexity is proportional to the smaller component, not the entire network. On a 90,000 node network, this can be 1 lakh time faster than traditional methods. So coming to the results, in real-time testing against classical data structures on 90,000 nodes backbone with 3 lakhs edges, Shutter Map query performance less than zero point 0.1 second, Union find 0.95 seconds but cannot handle deletions. But coming to the traditional BFS and other traditional data structures, it will take 319 million milliseconds for the same operations. Shuttermap doesn't just query faster. It proceeds 40,000 deletions in 4.43 milliseconds with maintaining complete accurate connectivity state. That's backbone grade performance, massive scale, real-time precision, 24 by 7 accuracy. So you can see the dashboards and the outputs and how the shutter map performs against the traditional systems. You can see the union find operation cannot perform deletion operation efficiently. It does not support actually. So that's why the shutter map plays a key role. So now let us understand why it is matters. When a fiber cable breaks in underwater trench or router fails in a data center, ISP needs to know immediately if you are still connected. Shatter Map makes that possible at scale. This means faster internet outage detection, automatic rerouting in milliseconds, not even in seconds, monitoring 90,000 plus nodes networks without massive infrastructure cost. It is just it is not just faster, it's enabling entire new possibilities for network reliability. So, coming to the conclusion, Shuttermap proves that something is best innovation come from understanding your specific problem. By recognizing the backbone network are spare and mostly redundant, researchers are built as structure optimized for reality, not theory. This result a data structure that as simple as fast and union find, but with power to handle the dynamic real-time demands of 21st century infrastructure. Thanks for watching. If you are curious about network algorithms, data structures, or how internet actually works under the hood. So see you next time. And you can see the outputs also here, how the system is being worked, the shutter map analysis, the operations we have been performed, the feature support matrix, deletion performance, and also overview. So you can see 90,000 router nodes, 3 lakh fiber links, 1 lakh 20,000 dynamic operations are being performed with a 99.7% safe deletion rate. You can see the build rate and also statistic query time. and also how the Shatter Map works. Thanks for watching again.